Hello guys, today we'll be looking at data science and machine learning series with Python, and we'll begin with the linear regression model. So what is linear regression? Linear regression is a supervised machine learning model in which the model finds the best fit linear line between the independent and dependent variable. All what it's doing here is finding the relationship between dependent and independent variable. Okay, so what are the steps we'll be covering here? First, we'll be looking at how we'll get our data. We'll perform exploratory data analysis. We'll begin with training a linear regression model. We'll evaluate the model. We'll get predictions from the model, and then perform our regression evaluation metrics. So for the first part of this series, we'll look at getting the data and performing exploratory data analysis. Okay, so let's head over to our Jupyter notebook and get cracking. Okay, so this is our notebook, and what we're going to be doing is we're going to be helping a friend predict housing prices for regions in the United States. So with our new data science skills, we said yes, and then we obtained the data from her. From what we gathered, the data contains the following columns: average area income, average area house age, that's the age of the house in the same city, average area number of rooms, the average area number of bedrooms, the area population, the price, and then the address. Let's get started. So first, we're going to import the libraries that we need in order to get all of this working. We're going to start with importing pandas. That's PD. We'll import NumPy. That's NP. We're going to be importing Seaborn. That's SNS. For our visualization, we also import matplotlib plus pyplot. That's PLT. And in order for us to see our visualizations inline, we're going to be using percentage matplotlib inline. Okay, let's run this. Now that we have imported the necessary libraries, let's check out the data. So we're going to import the data with USA housing. We'll say pd.read_csv. The name of our data is USA housing.csv. Okay, now that we have the data, we could check the head. USA housing.head. And we can see the head of the data where we have the average area income, the house age, number of rooms, number of bedrooms, area population, the price, and then the address. So the price is in exponential, so these are in millions. Okay. Now we could also check the information on the data. USA housing.info. And we can see that we have a total of 5,000 entries, 7 columns. The income is in float, the house age is in float, number of rooms is in float, bedrooms float, population float, price float, and address object. So the address is the only text we have in our data, and we can see that we don't have any missing data. So this is fantastic. We're going to proceed from here. We could do a describe. This is a statistical description. Statistical description. We'll be using USA housing.describe. So this is a statistical description where we have the count, the mean, the standard deviation, the minimum, 25% quartile, 50% quartile, 75% quartile, and then maximum. With the price, our maximum price is 2.4 million. Our minimum price for house is 1.5 That's about 150,000. Okay, so we could still do one more exploratory information on the data. It's going to be USA housing dot columns. So this gives us the names of all the columns. So these are the names of all the columns. Okay, now that we've seen the data and we ensure we don't have any missing data, let's perform our exploratory data analysis and create some simple plots to check out the data. Okay, we can start with a pair plot to see the relationship between all of the data that we have. Here we use our cbon sns.pairplot, call our data USA housing. Okay, here we have it, our pair plot. So where we have perfect correlations, we have histograms across them, and the areas where we see correlations between themselves, price and average area income. We could also see an house age, and we could also see in population. So this is a quick pair plot on relationship on all the data that we have, the numeric data that we have. We could also do a distribution plot, say test plot for the price. Let's see how the prices are distributed. So for the price, here we have it with our mean value somewhere around 1.2. So this looks like it's kind of normal distribution. It's similar to normal distribution. It's almost normal. So we could also look at another exploration for the data using heat map and check the correlation officially. So we use sns.heatmap USA housing .core. This is for the correlation on all of the data. As you can see, perfect correlation of 1 has that brighter color pitch across the diagonal, and then correlation of 0 goes to a dark shade. So where we have good correlation, 0.6 to 0.8 is between the price and the average area income, and then it moves downwards towards 0.4 for all of these portions, number of rooms, and then number of rooms, number of bedrooms. Okay, so there are many more other kinds of exploration we could do. We're going to have a pause here, and then you need to watch out for the next part where we'll be talking about training a linear regression model. We're going to continue from here. We'll split our data, perform a train test. So don't miss it. Don't forget to subscribe, join us, and see you in the next class. See you in the next part.